Hello there, Mr. Sutton here, bringing you the Algebra 2 11-2 Part 1 homework solutions on analyzing arithmetic sequences and series. In this one, we're focusing on the sequences. For this problem, we want to know if this sequence is arithmetic. So to figure that out, we're just going to see if there's a common difference. So -1 minus 1, that's going to be -2. And then -3 minus -1, that's -3 plus 1. That's also -2. -5 plus 3 is -2, and -7 plus 5 is going to be -2. So we have a common difference, meaning that this is an arithmetic sequence. To see if this sequence is arithmetic, let's check out the first differences and see if they're the same thing. So 8 minus 5 is 3, 13 minus 8 is 5, and that's already not a common difference, so no, this is not an arithmetic sequence. In order to write a rule for the nth term of this sequence and then get the 20th term, let's first figure out if it's an arithmetic sequence, because that would be very helpful. So it looks like from 7 to 12 we're adding 5, and also from 12 to 17 and to 22. So this is definitely arithmetic. We have a common difference. Here is our arithmetic formula, a1 plus d times n minus 1. And our d value in this case is going to be just take any term and subtract the one before it. So 12 minus 7, which is 5. So we have an a1 value of 7. That's our first term. So 7 plus 5, parentheses n minus 1. And then we just have to simplify this. So we've got 7 plus 5n minus 5. And then combining the 7 and the -5, we have 5n plus 2. Next, to see what a20 is going to be, we're just going to plug 20 in for n. So 5 times 20 is going to be 100, plus 2 is 102. To get a rule for this sequence, let's first figure out if it's a special one, like an arithmetic sequence. So let's see here. To get from 55 to 47, we're going down 8. Same thing to get to 39 and 31. So we have a common difference. This is an arithmetic sequence. That means we can use our an equals a1 plus d times n minus 1 formula here. This is our arithmetic nth term. The a1 is going to be our first term, which is 55, and the d, that's going to be the common difference. So there's a lot of ways to get that, but the easiest would just be 47 minus 55, which is going to be -8. So plugging those items in, we have an equals 55 minus 8 times n minus 1. Distributing our -8, that's going to be -8n plus 8. Careful with those double negatives. And then 55 plus 8 simplifies to 63. So we have -8n plus 63. That'll be our a sub n term. Now to get the 20th term like they're asking for, we'll just plug in 20 for n. So a20. And then we've got -8 times 20, which is -160, plus 63 is going to be -97. On this one, they want a rule for the nth term, and also they want to know the 20th term for this sequence. So taking a look at this here, to get from -1 to -1/3, it looks like we could get there by adding 2/3. Same thing to get these next two terms. So we appear to have a common difference, which means this would be an arithmetic sequence if the pattern holds here. So we can use our arithmetic formula, a1 plus d times n minus 1. All right, so the a1, our initial value here, is going to be this -1 right here. D, just take any of these and subtract the item before it. So for example, -1/3 minus -1, or plus 1. And that's going to be positive 2/3, which is what we're adding each time to get the next term. So plugging those in, we have a sub n equals -1 plus 2/3 n minus 1. And now let's just simplify this so we can distribute the 2/3. That'll be 2/3 n minus 2/3. And then -1 plus -2/3, that's going to be negative, let's see, this is like a -3/3, so that'll be a -5/3. So 2/3 n minus 5/3. Now to get the 20th term, we're going to go ahead and plug in 20 for n. So that gives us, let's see here, this would be 40 over 3 minus 5 over 3. So 35 over 3 then, if we combine all that together. For this problem, they're giving us the graph of the first few terms of a sequence, and they want the rule for the nth term, and also they want to know what term number 20 looks like. So just judging by the linear appearance of this definitely seems to be an arithmetic sequence. And if you look at the y values, 9, 6, 3, 0, we keep going down by the same amount. So with that common difference, we definitely have an arithmetic sequence. So we will use our arithmetic nth term formula. A sub n equals a sub 1 plus d times n minus 1. The a sub 1 value, that's the for term 1, what term 1 is, the y value specifically. So we have 1 comma 9, meaning 9 is my a1. For the d value, just take two consecutive y values and subtract them. So we've got 6 minus 9, and that gives us a d value of negative 3. Another way of thinking about the d value is basically it's the slope. We're going down 3 over 1, so negative 3. So plugging those into this formula, we have a sub n equals 9 minus 3 times n minus 1. And now distributing and simplifying, we have 9 minus 3n plus 3. And then 9 plus 3 gives us 12, so negative 3n plus 12 would be our nth term formula. And then to figure out the 20th term, we'll just plug in 20 for n. So negative 3 times 20, which is negative 60. And then adding that to 12, we have negative 48. For this problem, they're asking for a rule for the nth term of an arithmetic sequence. And they've given us the 20th term and the d value. Now, since they're telling us this is an arithmetic sequence, we can go straight to our nth term formula. So a sub n equals a1 plus d times n minus 1. We've got the d value already. In order to actually fill this thing out, though, we need the a1. So to get that, I'm going to plug in this 20th term. So a sub n, I'm going to replace that with what the 20th term actually is, negative 27. And then a1 is what we're looking for, so that'll stay as a sub 1. For d, we're using negative 2. And then for n, we're using 20 because I have to plug 20 in for n in order to get this negative 27 out of whatever formula I come up with here. All right, let's simplify this a little bit and solve for a1. So 20 minus 1 is 19, times negative 2 is negative 38. And then to get a1 by itself, let me just add 38 over here. Negative 27 plus 38 gives me 11 for that initial term. And now I can plug that back in. So we're going to end up with a sub n equals 11 minus 2 times n minus 1. Let me just simplify this now. So we have 11 minus 2n plus 2. And then that can simplify to negative 2n plus 13. For this problem, to get a rule for the nth term of this arithmetic sequence, let's start with the arithmetic nth term formula. A sub n equals a1 plus d times n minus 1. So we have the d value. We need to figure out the a sub 1 value to complete this formula. So what we're going to do here is plug in our d value that they gave us, and we'll also plug in this 11th term of 43. So a sub n, we're going to actually use a sub 11 for that. So we're going to do 43 right here. Equals, a1 is still going to be a1, we're solving for that, and then our d is 5 here, so plus 5, and then parentheses, to get 43 we had to plug in 11, so we'll do 11 for n. Alright, let's clean this up a little. 11 minus 1 is 10, times 5 is 50, and then subtracting 50 over here to get a1, we have negative 7 for that. Now I'm going to plug all this into my a sub n formula. So I have a sub n equals now negative 7 plus d value of 5 times n minus 1. And all I have to do at this point is simplify this. So we have negative 7 plus 5n minus 5. Negative 7 minus 5 is negative 12, so 5n minus 12.